So students, let's do question number 3. We are given the following information. Find the first 3 terms in the expansion of 3 negative 2x raised to the power of 5 in ascending powers. Right? Now we know the binomial expansion, right? So you can state that we know the solution. We know the following binomial expansion. So what is that? A positive b raised to the power of n is given as sigma k is equal to 0 to some value n, and then nck times a raised to the power of n minus k times b raised to the power of k. Now nck is n factorial divided by k factorial times n minus k factorial, and given, what is that? We're given 3 negative 2x raised to the power of 5. I'm going to rewrite it as 3 positive of negative 2x raised to the power of 5, where a is equal to 3 and b is equal to negative 2x, so that we can have this form. That's the basic idea. So therefore 3 positive of negative 2x raised to the power of 5 is equal to sigma k is equal to 0 to 5ck times 3 raised to the power of n minus k. That means 5 negative k times negative 2x raised to the power of k. Now I'm going to write the terms. When k is equal to 0, you get 5c0 and 3 raised to the power of 5 minus 0, negative 2x raised to the power of 0. And k is equal to 1, 5c1 times 3 raised to the power of 5 minus 1, negative 2x raised to the power of 1, positive 5c2, 3 raised to the power of 5 negative 2, and negative 2x raised to the power. We have now the following: 1 times 3 raised to the power of 5, positive 5 times 3 raised to the power of 4 times negative 2x, positive 5 times, it's actually 10 times 3 raised to the power of 3 times negative 2x raised to the power of 2. Right, now this 10 we got it from that evaluation of the third term. Now if you were to rewrite this, this is going to give you 3 raised to the power of 5, that's going to be 243. This is going to give you 3 raised to the power of 4, that's going to be 81, multiplied with 5 ones are 5, 5 8s are 40, multiplied by 2, right, 5 2s are 10, 1 and 8. So this is going to give you 810. Now you got an x there, followed by 3 raised to the power of 3. That's 27 times 10, that's going to be 270, multiplied with 4. So 7 4s are 28, 2 4s are 8, 9, 10. So you get 1080. So all these things are working, is for your understanding. And followed by 1080 x squared. So final answer, conclusion. You can put the conclusion here. So therefore the first 3 terms are 243 negative 810x positive 1080 x squared. So that's the solution for the first part. Now we need to do the second part also. Now for the second part, this is part 3b, we are asked to find the coefficient of x squared in the expansion of 4 positive x raised to the power of 2 times 3 negative 2x raised to the power of 5. Now what I'm going to do is I'm going to first consider, this is a solution, consider 4 positive x whole squared. Now what is this? You expand this, you get 4 squared, positive 2 times 4 times x times positive x squared. You rewrite this, you get 16 positive 8 times x positive x squared. What is this? This is 4 positive x whole squared. Now you consider the next term. Consider 3 negative 2x raised to the power of 5. I'm going to rewrite this as 3 positive of negative 2x raised to the power of 5. Now this is of the form a positive b raised to the power of n, which has an expansion as k is equal to 0 to n c k a raised to the power of n minus k times b raised to the power of k. So using that, what do we get? So therefore 3 positive of negative 2x raised to the power of 5 is equal to sigma k is equal to 0 to 5 c k times 3 raised to the power of 5 minus k times negative 2x raised to the power of k. Now remember, when we multiply this component, or I would say this component with this component, we are looking for x squared, so we don't need to go to higher powers. So when k is equal to 0, I'm going to write the first few terms. K is equal to 0, you get 3 raised to the power of 5 minus 0 times negative 2x raised to the power of 0. That is one term, because we got an x squared here. Fair enough. Next term 5c1 times 3 raised to the power of 5 minus 1 negative 2x raised to the power of 1. So this will also produce an x, because x squared term, because there is a x here. So next is 5c2 times 3 raised to the power of 5 minus 2 negative 2x raised to the power of 2. Now we don't have to go to the next term, because that is going to be producing 3. So we stop right here. So evaluating, we get that quantity that we got in the above evaluation. So we get 243 negative 810x positive 1080 x squared. This is what we have got. Now this has to be multiplied with 4 positive x, the whole squared, and 3 negative 2x raised to the power of 5, isn't it? So this is equal to, this we have already got, and that is going to be 16 positive 8x positive x squared times, this is going to be this 243 negative 810x positive 1080 x squared. Now this multiplied with this, so 1080 multiplied with 16 will give me x squared term, and then this multiplied with this, so negative 8 times 810 will also give me an x squared term, and this multiplied with this, so 243 times x squared. So now what we need to do is we need to collect these terms. So 1080 times 16, so we need to multiply that. 1080 times 16, 0 48 4 6 and a 0 and a 8 and a 0 and a 1, 0 8 12 7 1. So this is 17280. This is one term, and we need to actually collect the total sum. So 8 zeros are 0, 8 ones are 8, 8 eights are 64, and then 243. So I'm going to place 6480 here. It's a negative, so 0 0 8 6 0 1 0 8 0, and then 243 has to be added, so 3 4 10 1 1. So the value is 11043. So that is the solution.